Yes. All right, so the question up in front of us now is, what is a test statistic? And for our purposes, since we're only doing means and proportions, for a mean, the test statistic is a z-score or a t-score. And it's based on the sample. For a proportion, it's a z-score. And all of these are based on the sample. And the null hypothesis. So for a mean, the z-score is going to be your sample mean. And we did z-scores. This is way back from section 2.6 or 2.8, somewhere in there. So it's always the value you have minus the main value, like the population value, then divided by the standard deviation. And the standard deviation is either sigma over the square root of n, or if it's a t-score, we don't know sigma, it would look pretty similar. It would be s over the square root of n. Proportion's pretty similar, but we got to switch out a proportion. Proportions always use z-scores, and it would be the population, the sample proportion minus the population. So that's kind of like x bar and mu there, and then divided by that square root, p times q over n. So if we look at my picture from before, when I was counting my z-scores, so it's my standard deviation, so the 0.36 is about 1 standard deviation to the right. This is about 2 standard deviations to the right, and the 0.4 was 3. So this proportion should have a z-score that's somewhere between 2 or 3 to the right. So to calculate that here, its z-score, which in this context is also called a test statistic, then I would take that 0.456-ish, so that's the rounded version of that number, minus the population, 0.3, and then divide by the standard error, which would be the square root of, oops, let's use the actual values. Whoa, come on, pen. 0.3. Q would be 1 minus that, so that would be 70%. And then I had a sample size of 68. And so then I would whip this out on my calculator. And depending on your calculator, you might have a parentheses for the square root, but you also need a parentheses for the denominator, and you need a parentheses for the numerator. So, and let's see, did I have test statistics on here? Anywhere? We have the sample proportion, we have the standard deviation. I didn't put a spot for the test statistic on here, but if I wanted to add that in, test stat, which is a z-score, it would be parentheses, my sample minus the population from the null divided by, and then SQRT is kind of it's got its own parentheses, and that would be P. I don't have the Q here, so I'm gonna have to go times parentheses 1 minus P. That calculates Q, close the parentheses, and divide by the sample size. Where's that? Right there. Close the square root. So my test statistic is about 2.8. And again, I had tried to sketch that in my picture. I drew it at more of about a 2.5 z-score, so it should have been a little bit more to the right than I drew it. But it was the best I could do at the time, kind of eyeballing these measurements. And StatKey does a better job of drawing that. So that would be the test statistic there. So that'd be a good thing to put in the notes. So what did I calculate? 2.81-ish. How many decimals? Mine wants 3, so 2.805, I think mine was. My p-value is about 0.0025, if I remember right. That is less than alpha, so we will reject the null hypothesis. Oh, and then we have to pick the right conclusion, which I already wrote up. And these are kind of tricky because I screw up the wording, and sometimes multiple choice suck. There is sufficient evidence to warrant rejection of the claim that the proportion of stocks that went up is more than. No, we aren't rejecting that it's more than. That was the alternative. We're accepting that. There is not sufficient evidence to warrant rejection of the claim. Not sufficient evidence to reject, which means we fail to reject. No, that doesn't look right either. Sample data support the claim that the proportion stocks that went up is more than 0.3. That looks right. There is not sufficient sample evidence to support the claim that the proportion of stocks that went up is more than. Not sufficient evidence to support the claim. These are tongue twisters. I'm leaning toward this one. Yeah, I'll go for that one. Ooh, got it right. Okay, so let's pause and do one more.